Good morning, everybody. Thank you for joining me today. I'm very excited to be here. So let me just start off with this number. I want to talk to you today about the fact that 60% of time in data processes is spent on data preparation. 60% of time is actually wasted on stuff that people shouldn't be doing, and it's caused by bad data quality, by inefficiencies in processes. I think this is a staggering number, and I think it's a big problem, and we need to try and solve it. So what I want to do today in this talk is I want to talk about something that I call small data and low data quality and how it impacts business processes. Then I want to talk about how teams end up in Excel hell due to this. I want to talk about the different kind of data processes that I distinguish and why they're so, what's causing these problems. I want to show some examples of small data in the wild, so to say. So what we see, what we encounter in our daily work. And finally, I will go over what we as a company believe is needed to better deal with this kind of data flows. And I'll guide you through some of the thinking that we're going through there. But first, let me introduce myself. My name is Mark. I'm from Amsterdam. I live there with my wife, 3 kids, and my dog. I have a background in IT and finance, so a lot of what I'm telling you today is informed by my experience in that business domain, so to say. I've always had a very keen interest in how you make systems talk to each other, how you make applications communicate, how you integrate data so you can have an efficient reporting process and basically create a smooth process around that. But maybe just jump back a little bit further. I think as a kid, I was always fascinated by computers. They were these kind of magical machines to me that were supposed to make our lives better. And it also puzzled me why people, at a library desk or check-in in an airport would spend so much time typing things into that computer screen. I never understood why it took so long, right? I mean, it was always, I was thinking computers should make our lives better, but it always seemed to make things more complicated. So I was a bit puzzled by that. So I think that experience and that fascination drove me into going to study computer science. And when I kind of fast forward, say 15 to 20 years, I find myself in a financial services environment because this is where I thought, as an IT guy, I needed to be, because basically a bank is a large hard drive and it must be full of cool technology and interesting, innovative stuff. So that guy with the 16 screens, that was going to be me, and I was just going to go in there and do really cool tech stuff. But I was kind of wrong, because I think what you see in financial institutions, especially the ones that I've worked in, they're also full of people, full of processes, rules, and also a lot of fax machines still. So these haven't been ruled out yet. And there's loads of Excel sheets going around. So that was a bit of a shock for me that I was expecting to join and do interesting stuff, but in fact, I got a reality check, because building business applications that work for bank, and especially for people in the bank, it's not just about technology, it's about security, it's about maintainability, it's about getting a return on investment, it's about architecture, it's about risk management. So that took me a little bit longer to figure that one out. And I think banks are not unique in that respect. I think you probably see this as a pattern in a lot of larger organizations, basically. Okay, so I think today there's a massive amount of buzz and talk about big data and artificial intelligence, machine learning, and that's super interesting. At the same time, I think There's also another side to the business, which is maybe more administrative. It's less about massive data volumes, but it's about more transactional processes. It's getting data into administration systems, getting reports ready for management, getting reports ready for clients, or getting reports ready for regulators. I think that is an area where there's a big impact to be made, because a lot of time is lost in those kind of processes. And that's why I'm saying I think small data is a big problem. And when I'm talking about small data, I'm really talking about data that's, it's not streaming, it's not gathering events from POS or ATM machines. It's more ad hoc data. It's lower in volume. It's typically exchanged manually through emails, through portals. It's lower volume, higher value. These are typically typical examples of things like real estate transactions, portfolio valuations, the outcome of risk management models that need to be evaluated by someone. So, and the data quality, I think, if you talk about this kind of data, is a lot lower. It's not so standardized. Most often there are no formal agreements as to what the data needs to conform to. So that makes dealing with that data kind of problematic as well. And I think if you look at the data quality and the effects that that has on an organization is basically waste. You introduce cost, risk, and waste, and it's wasted time. It's frustration of people spending their time on the wrong things, getting frustrated by the quality of the data. You risk reaching wrong conclusions in your models. You risk informing wrong decisions. You need overqualified people to do things, or you're actually underutilizing people by letting them doing work that's actually not really up to their level. And you rely overly on key man. You create a key man risk basically by having certain people that can always fix things and know the data, know the business domain so well. In short, actually, you cannot automate these kind of processes properly. I think instead what you need is you want to spend as little time as possible on preparing data and getting data to a shape that you can actually use it. And at the same time, you want to have control of that data. You want to understand what the data is. You want to understand what happened to the data. You want to understand that the data that you're seeing is correct and can be used safely in your process. I think ultimately what you want to get at is something that I like to call data clarity. And it's not 100% data quality, but it's an understanding of the quality of the data that you're dealing with so that you can make an informed decision about using it in the next step of your process. So sometimes data doesn't have to be 100% perfect, but an 80% is good enough for that particular use case. And I think that also, that realization, but also that information at your fingertips kind of gives you the ability to speed up your process. So the 60% number wasn't grabbed from thin air. I think what you see is that unfortunately good data quality is not the norm. I found 2 pieces of research from the data science community and from another study that actually indeed show that a lot of time is wasted on getting data into shape to further, to actually get to a point that you can actually start the actual work that you're doing. And I think you see this happening in a lot of organizations. You see effort and time leaking away in data preparation processes. And I think if we're talking about data preparation, what I'm talking about is it's the collection of data, it's the validation of data, it's the enrichment, reconciliation, and reshaping and reformatting of data, which those 3 I bundle under sort of transformation of data. And then finally, there is the delivery of data. So these are all steps that happen in a data-intensive process. And I think what you see a lot is that these steps are kind of hidden or taken for granted or seen as part of the work that people do. They're not recognized as discrete steps in the process, and hence it's not much, and maybe people don't notice it that much that they're doing things that they're actually not supposed to be doing. So I think if we talk about data processes, what are we talking about? I think there are two sort of extremes in there. There's data entry and you've got data analysis. And I've kind of put them on a spectrum because that correlates kind of with the kind of skill sets that are required, with the variability of the data, with the frequency of the processes, and the kind of the volume of the data. I think if you talk about data entry is very much about transactional workflows. So it's gathering data, entering that data into an administrative system, putting it into a data warehouse, it's quite an operational workflow. If the data quality is low there, what you see happening is mistakes are being made, but also work then kind of transforms into data preparation work. So the fuzzier the data is, the messier the data is, the more work people spend on assessing the data before they're putting the data into the system. And I think you see a similar pattern in data analysis, but it's kind of the other way around. So if the data into a data analysis process is of low quality, you see maybe your smart quants that you've hired working on actually quite mundane stuff to get data into shape to actually be able to process it further into your models. Bottom line here is that I think data preparation is input into both these kind of processes, but by lifting them out and separating them out as separate steps, it allows you to start thinking about it and thinking about optimizing those steps in your process. So I think what people do is basically people can give up in these kind of situations, or they tool up, and typically this is what they do. So they use Excel basically to fix their own problems, right? So Excel is obviously the most brilliant tool ever invented, in my opinion, and you can basically do anything with it. I've seen multi-billion portfolios being managed on Excel that got so big that just refreshing all the cells would allow the portfolio manager to get a cup of coffee for his whole team. And you can probably think of examples as well in your daily practice. And in fact, there is a whole website dedicated to this. It's quite an entertaining web page of horror stories around Excel. So things that went horribly wrong because of Excel. So I think people tend to resort to Excel or sort of custom-built solutions in their end-user computing environment. So, the proverbial intern is never far away. It's this guy, smart guy or girl that comes in and builds a smart solution for you. And it kind of works. It works really well. Until the intern leaves, or the lady that built the macro wins the lottery, or IT decides to upgrade Microsoft Office and all your macros are screwed, basically. So there's quite some problems with it as well. As I said, this approach breaks down. So I think if you see Excel as a solution to speed up your data preparation process, you kind of give up on other things. So in a situation where you've got this nice macro zooming along, that's loading all your data and making data ready for the next step in your process, you're giving up on a large part of the control and compliance. So, and also, this data clarity is not always obvious. So understanding the data quality in all of that documents that you're getting in is kind of hard. So it's really this kind of elastic band that you can only stretch so far. Similarly, you can IT will come up with systems that greatly increase the control and compliance of your processes. But those are typically solutions that don't really work very well for business users. They need more flexibility. They need more freedom to work with. And because this data often comes in emails, Excels, PDFs, these kind of products also break down very quickly. And hence, they don't really shorten your preparation time either. Data clarity is something you could achieve in an Excel kind of based environment. But it would almost mean you would need to go into each and every sheet, run macros, understand what your data issues are, but it doesn't give you any kind of way to manage data quality issues in an environment like that. So this is quite an interesting challenge. in my mind. We started a company to build services and products around that, and we're trying to solve this, this problem. And I will talk a little bit more about that later on. So let's go back to the data preparation process, right? So as I said, it's inputs, it's collection of data, it's validation of data, transformation of data, delivery of data. And I think what makes this process so complex, because in essence it's not a very complicated process, right? It's a couple of steps. But what makes this complex is the data containers that are input to a kind of process. And these are kind of the data containers that I kind of club under the small data term. And by data container, I mean really a vessel for data. So you can have a PDF that has data in there that you need in your process. You can have an Excel that has data in there you need in your process. So the variety of those data containers makes this process complicated. To go on this a little bit further, I kind of put them in a kind of a matrix. So on the horizontal axis, we have something that tells you something about structure of the data, and I'm doing this to kind of go into a little bit more detail on why these data containers are so problematic. And I think you've got hierarchical, structural data in documents. So this is data that's grouped, or it's pivoted data. It's not in tables, but it's kind of in summaries, or it needs to be grabbed from paragraphs. And there is an axis, and there is flat tabular data. So it's super structured. It maps very nicely to a relational database. And then there is kind of the human readability versus the machine readability on the horizontal axis. And I'm going to discuss some of these examples in a counterclockwise fashion. So first, this is an example of an Excel file, which is used to report quarterly. This is something that I've seen in my work. It's an Excel file which is used to report on real estate portfolios. So this is delivered quarterly to investors in a real estate portfolio, and it informs them about the performance, about the fees, and about all about the company, the buildings that they're invested in, etc. A larger pension fund would get 100 of these, all separate and all about one of the investments. So just going into this and grabbing data out of it is just a big pain, because you would need to go open each and every spreadsheet, get the data out, and then maybe copy it into another spreadsheet. But this, and basically this is an Excel sheet that's being used as a form, and in the end, people are just typing this kind of stuff over because there's no practical way of pulling it out or building their own macros and be a little bit smarter about that. This is an example of an Excel file which kind of has a nicely tabular form. So this, in theory, this is reasonably easy processable, right? So you can load this into a table and then you can work with it further. But then what screws things up is header information on top telling you something about the reporting date or about the fund that this is for. The header can move around, depending on who prepared the report or what. It can be on different tabs as well. You can have merged cells. And finally, in Excel, you have regional settings, which can screw you up as well. So you have a document prepared by someone in the US, you open it in Europe, and all your number formatting and dates are wrong. So in theory, Excel is quite nicely readable, but it's the format itself kind of leads to a lot of problems. This is another example of a PDF file that we encounter as well. This is something that is used in a lot of reporting processes. So typically things that are lifted out of this document are key facts that are on the right, or it's a table that you need to pull out. And in the end, people resort to just keying in this data because there's no real other way of doing it. These are two examples of tables. So this is tabular data. Which again is reasonably well structured. So in theory, it's something that you could parse nicely with an automated process. But then the PDF kind of makes that a little bit troublesome. So you need some kind of recognition of the table, and especially in an end-user computing environment, copy pasting this data is just not really possible either. And I think finally, on the top right, there is CSV data, and this is obviously a preference of anyone building an automated process, is getting this kind of data, because this is something that you can actually read in nicely, put in a database table, and gives you a lot of structure and a nice standardization. Actually, what's actually funny is that reading this into Excel actually might cause more problems than just having an automated process in place. So this kind of, I hope this kind of clears up the problem space that we're looking at. And I think if you have all these, if you have a process that has all these crazy data containers coming in, and I think these are the departments, a lot of departments and larger organizations that struggle with this this problem. I think what you need, as soon as possible in the process, is to create a holistic view on the data. So to get to a sense of data clarity on that data. If you have that, it allows you to make decisions in your process. It allows you to say, okay, well, we're actually not moving ahead, or we can actually go ahead with this part of the process, but we need to wait for that. I think that is really important. Aspect of this, and I think. And what we've seen is that I think data preparation processing. What we've seen is that data preparation processing for doing this across many different data containers is a pain in the ass, basically. I mean, you can't do this in an efficient manner, and you cannot do it in a controlled manner. So I think to get to an optimal process, you need to shorten the preparation time, and you need to increase control. And again, I think then we're back to this this problem of supporting contradictory requirements. So we're back to that elastic band that we talked about previously. And what you want to do is you want to move data out of those data containers as soon as possible, so you don't have to deal with those anymore. And you want to provide easy access, make data shareable, and allow review of that data. Having it in one place allows people to work with the data, to modify the data, to query it, and to reshape it as they see fit. So I think I've talked a lot about a problem that we were trying to solve, and I probably think you're now wondering from how do you solve it then? I mean, that's probably a more interesting question. So how do you build that bridge between those two worlds, right? The messy world and the structured world of IT. So to do this, I want to kind of start off with a slightly bigger picture, and I don't want to do a demo or anything. I just want to talk about this problem in, I would say, in more conceptual terms. And so I kind of visualize the bridge as a kind of a couple of functional components that we have, or that you can have, and that can make that connection. So on the one hand, you've got, say, the messy data coming in all these different shapes and forms, and you need to pull that data in somehow. So, and you need to present that data back to the user. So there's a user interface. User interface takes care of workflows around the data. It tracks the delivery of data, so you can make sure that all your data has been received. It allows you to interact with data issues, data quality issues, issue resolution. It allows you to fix data and build configurations that are repeatable. So you get a document in once, and you can build a repeatable process for the next time a similar document comes in. It allows you to drive the transformations, and it allows you to track delivery of data, and also allows you see that delivery agreements have actually been adhered to by the party that's received the data. So next down, I think it's the processes that we've talked about. And then there is a data abstraction layer. Data abstraction layer is basically responsible for marshalling data in to the data stores from the documents and marshalling it out again to the various processes and the user interface. The data is stored in two kinds of storages. So we have this document store, which is basically a store of all the serialized documents, and there is a metadata store, which drives the user interface and drives the processes and contains metadata on all the data containers that you've been processing. So I want to talk a little bit more about how we do that data abstraction and how we store the data, because in my mind that provides the cornerstone basically of that, I would say, of that automation and the shortening the data preparation process, because it allows you to start to automate the collection, but it allows you to automate validation and transformations as well. And it gives you that control and compliance in a process, because you have the data and you can track everything that's happening to it. So I'll talk about those things in the remainder of the slides. So this is a super simple picture, but it should almost be as simple as this. So we get documents in, so we get PDFs in, we get scanned faxes in, we get Excel sheets, we get CSV files, and those need to be serialized and dumped into a database. We store we store these documents as in a document store. So we heavily rely on a JSON-based serialization of documents, and so so for example, for a PDF file, every individual text item on a page will be stored as a separate document in a Mongo database, and it will get an ID and it will get coordinates on the page. So we can always link it back to, we can always link an exact text item back to where it came from on a page, and can make it uniquely identifiable. For images, we do a similar process. We OCR it, we add a text layer, and we process it like a PDF. CSV files and Excel files are in that sense quite similar, because each and every cell in an Excel file or a CSV file is saved as a separate document. So every data item is individually identifiable with its coordinates. So in terms of an Excel file or a CSV file, this would be rows and columns. So the place where you find it in the document. So it allows to easily reconnect with it. So how do we do that? So this is just two snippets of how we store that data. So in the PDF document, you see we run a process to extract this text data, and it's basically JSON. It's super simple format. It's JSON documents, and it has coordinates in there which we normalize, so we make our own lives easier in sort of playing it back to the user interface. And you can store some metadata around the styling of a cell or of a text item in there as well. We can grow this data model as we go, so it's not fixed. And if we find something that works better, we can switch to that as well. And I think that the data abstraction layer makes that easy to do for us. I think the next pillar in, I would say, the whole control framework or the whole control requirements you need to have is an audit trail. So you need to understand, the company needs to understand who changed what data and why and when. The why is maybe the hardest to do because that's kind of a subjective measure, but who's done it and why it has happened is quite important. Not only is it important for a company, but it's also important in terms of regulation, because what you see the last couple of years is there's a lot of regulation that actually makes this a requirement for a company to have this sorted out. So you need to be able to prove to your regulators that you're in control of your data management processes and that you actually understand what's going on under the hood. So an audit trail feature in an IT application needs to make sure that this requirement can be supported. So the way we do that is we have all these data items stored as separate documents. And we can add an attribute to that, which basically tracks the history of that particular data item. So a user can make changes through the user interface, and those changes can be persisted on that particular data item. And this gives you super granular control and can replay changes. And it's quite a simple but effective way to track all this stuff. Once you have this, you can have all kinds of workflows, like if a cell has been changed or a data item has been changed by a user, it cannot be changed by the same one, or you can force a review of that data item before you can do anything with a data set that has changes on it, etc. So this is quite a simple but powerful mechanism. And I think the final piece of the, I would say, the control puzzle is data lineage. So data lineage is a term from data management which talks about understanding the flow of data through a system. So if you have a data set that's been created by your system, you actually want to be able to understand how that data item was created. So how can you play that back? So and again, lineage is also quite an important requirement for audit and regulation purposes. And if you look at it in terms of the data preparation process that we've been talking about, I think this allows you to actually speed that process up as well, because you can be much quicker in finding bugs or problems with your data and understanding why things happened in a certain way. So again, it helps you with that preparation process. The easiest way to do this, obviously, would be that you have a data set to data set lineage. So you can say, well, this data set was created by combining the data of these two other data sets. But it becomes much more interesting if you can actually do that on a data item level. So you actually want to say, well, this data item was sourced from that data source, and it was sourced from that particular cell in that Excel sheet. So if you can get that kind of relationships going on, it becomes quite an interesting game. And again, the way we do that is in any kind of target document. So we're mapping data from, say, a PDF document into an Excel file, transposing data, putting it in an Excel file. It actually allows you we add a source attribute to that target cell, which contains the source, links it back to that PDF document, and it records all the operations that have been applied by the transformation engine in that process. So I guess by just having all this data in one place gives you kind of an interesting playground for end users to work with that data, to build workflows around that data. And the JSON model here helps us kind of iterate quickly around user requirements and have an experiment with how we do this. And be pretty flexible in not having to set up database tables to load in data, which you typically find in more traditional ETL processes. This kind of brings me to the end of my talk, and I think what I set out to do was to sketch a problem, which in my mind seems is sometimes super obvious, but it's often hidden in companies, right? It's hidden under, this is the way we've been doing things for 10 years, or people don't really recognize it as a problem because it's just so ingrained in their day-to-day work. I think I've discussed how we go about this process, so we kind of avoid any structure, bringing structure to the data at an early point in the process, but we leave that to later on. which gives us a lot of flexibility to respond to business requirements, respond to low data quality, and be able to fix it. And I think it hopefully shows that you can, by having an approach like this, you can provide data clarity to the user in a short span of time. We've run this as in projects. I had a couple of clients in the Netherlands, and a particular example I think that is interesting is that we were doing this for a client that had a quarterly reporting cycle, and basically it took them 3 months to report on that other quarter. So you were working a quarter to report on the previous quarter, and they're working with a team of 15 people to do that. Once we started to bring in this kind of software and methodology, we were able to bring it down to 15 days. So that's a kind of an 80% improvement. And I think the number of people that were needed to run the process went down to 3 or 4. So I think those are quite big improvements. And I think if we can have this approach, and we can bring this approach to other companies as well, I don't think this needs to be limited to the finance domain. I think we can bring, we can win back a lot of time, basically, of people working with data. So I would like to thank you very much for bearing with me, and I think the floor is open for questions, if there are any. So thank you very much.
Thanks, Mark. Amazing. Do you have a question, guys, over there? I just check on the webpage and I cannot see questions, but I have one for you. So you mentioned at the beginning that this is about small data rather than big data stuff. And also that you are using MongoDB at the back end for storing data, right? And also you were talking about regulations and a lot of things to do with audits. Mm-hmm. So have you thought about using blockchain technology just to avoid this kind of third party to give that kind of service, so that guarantee that somehow you're tracking your data, you're not changing anything, but just there it is, so the audits are easier?
Yeah, that's an interesting thought. I think we talked about it a couple of times, we've entertained the idea. I do think that typically the solution that we're building would be something that would be internal to a company. That's initially, I think, where we're going. So a blockchain might be an interesting solution, but I do see performance issues with it. You want to actually be able to query the data, and I don't know how that would work in a blockchain. I mean, you could maybe
it's a combination of both.
Yeah, I think that might be interesting. We thought about it, but we haven't really investigated it that much, to be honest.
Okay, thanks. I'm going to check just in case we have more questions. Oh, yes. What is the pricing of the product? Someone's asking. Yeah.
What's the pricing of the product? Yeah. Well, we can talk about that offline, I guess. But yeah, we're very cheap. Yeah.
Oh, it's cheap. Yeah.
Cost effective.
Okay, thanks. There's another question regarding the IT. Is the tool used by business user or by IT?
Business users. So this is an interesting question, actually. I think if we talk to IT, the typical reaction we get is, "Oh, we can do that." And I think this is exactly, and it's back to that slide that I had on the elastic band. It's if you, IT will typically come with the solutions that they buy, right? So these are the typical large-scale data applications that promise that they can do everything. But I think what I've personally seen a lot is that these solutions often lack a connection with the business user. So they don't provide insight into the data, for example. So you can automate things, but the business user doesn't have a clue what's going on under the hood. So he will see the end result, but that doesn't necessarily give him the visibility on what's happening. And then just trusting the data that comes out on the other end is kind of difficult. So we tend to try and talk to the business users about their problems. And I think also it's because you can show you've got an understanding of what they're doing, and it can give a lot of confidence.
So you are the only IT guys behind the scenes?
Sorry?
You are the IT guys behind the scenes, right?
Yeah,
So,
well, I think we're IT guys that understand the business problem. And I think that is a powerful combination. And I think in large organizations, that connection is sometimes, I'm not saying that's everywhere that's the case, but in a lot of organizations that I've been, I see that connection is sometimes lost. And you can actually deliver solutions in a more, in a smarter way.
The last question here is about the process itself. They're asking what are the differences between this process and a traditional ETL?
That's a good question. It's very similar to an ETL process, I guess. I think the different approach that we take is in an ETL process, typically it follows these similar kind of steps. An ETL process, I think, more focused on automation. So it's that pipeline that just runs in a batch every night or every morning, and if it breaks, somebody from IT looks at it. It doesn't necessarily give that transparency to the users. And another difference, I think, is in ETL processes, usually data is kind of pulled out into some kind of staging table, and then it's moved through different stages in the process. And I think where we are kind of more, we're not having any preconceived ideas around the data when we store it. We just chuck it in as a serialized blob, basically. And we can work out later what we need and how we need it. So that allows us to very quickly add new sources, so you don't have to go into configuration and set up tables before you can add a new source. And it's also, I think, more linked to the user process, so the user can operate it himself. He can upload data, can put data in, and it caters more to an ad hoc workflow rather than a sort of very predictable kind of thing that ETL typically caters for.
There is one more question. This is about data silos. So the question is, if this kind of project done behind IT could not result in a data silo separated from the enterprise data warehouse, resulting, for example, in number differences?
I didn't quite get it.
I just read it literally. I think that is just trying to say if this is not IT driven, if some of the data will be just lost, will not be correlated, or.
So you're saying the data could be lost if you take an approach like this?
Yeah, well, data silo is like isolated data.
Yeah, I think the end goal of this would be that you can connect it to those more formal data silos. So the output of a system like this would be a feed into a data warehouse, so you avoid losing that data and you keep it. And indeed, to not create another data silo that sits somewhere on its own, and you want to actually integrate it with the formal technology that I mentioned in my title. I think that's definitely the goal of this. So not something that sits on its own, but is connected. It kind of makes that connection possible between that unstructured end-user computing world and formal technology.
Thank you very much, Mark. That's all. So
thank you.
Nice to have you here. Oh, one question.
We have another question here.
Thank you, Mark, for the marvelous presentation. I'm Antonio Botella, working for Oracle, and I have been working with integration and middleware. For me, what you have been showing is a big problem that a lot of companies have, having their data in Excel files, sometimes hundreds, thousands, millions, and it's a way of consolidating the data into data lakes and databases. Exactly, your company, what they are doing is basically giving an integration solution in order to consolidate this data. How are you competing with other companies? Because, for instance, in my case, Oracle has products that are focused on this kind of integrations, doing this thing.
I think it's almost, we would I think we would be we wouldn't necessarily compete with those kind of products. I think we maybe almost an add-on, something that can reach into the user organization, make that data ready for consumption by those integration products. I think there's different layers at which you can view integration. For smaller companies, this might be all the integration you need to do. For larger companies, you can imagine that this is a way to connect departments with a broader integration framework. Does that answer your question?
Are you thinking in the future, or can you think on working with other major brands, giving you or helping you on that task? Do you want to achieve this goal for bigger companies?
To work together, you mean?
Yes.
Yeah, yeah, I think that could work. Yeah.
Thank you.
Okay.
Thanks a lot, Mark. Big applause, please.
Thank you very much.